Hello everyone, welcome to Coders Camp. We are 28th day of December LeetCode challenge, and the problem we are going to cover in this video is middle of the linked list. So which is the easy category linked list problem where we have used the same concept in many big linked list problems as a small sub problem. So if you are familiar with our linked list problems already, you must be aware of the solution by now. If not, if you are the first time learner, then it is a very good practice or very good problem to start learning the linked list and how to solve a linked list problem using pointers. So let's dive in. Here the input given is head of a linked list, and we have to return the middle node of a linked list. And if there are two middle nodes, then return the second middle node. So let's understand this with an example. So here's the given example, and we have to return the middle node of a linked list. So let us consider only there are 5 nodes in the linked list. In this case, which one would be the middle node? There are 2 nodes in the front, 2 nodes in the back, and 3 is the middle node, and this is what we are going to return. So here they did not ask for the value inside the node, but we have to return the node itself so that the head of the linked list would follow the rest of the nodes in the linked list. So this is done, and what if there is another node in the linked list, that is the sixth node as well? In this case, if there are two middle nodes, then we have to return the second middle node. So as the problem statement said, there are two nodes in the front, two nodes in the last, and two nodes in the middle. So these two are the middle nodes. In that case, we have to return the node 4 as our output, and here again the value should not be returned, the node itself should be returned. So how are we going to approach this problem? So this problem is one of the usually frequently asked problem. In many big problems, we use this sub problem to solve them. So there are many ways to solve it, and let us learn the optimal way. So before getting into the optimal way, the very long way to solve this would be iterating the linked list to find length of the linked list so that we identify what is the length and what would be the middle or the in the half of the linked list. So if we iterate and increment our counter, the counter will be incremented 1, 2, 3, 4, 5, 6, 6 times to identify the nodes, the linked list length. So now if 6 is the length of the linked list, then the mid node would be at 3. So since this is an even number and we have to return the second middle, if there are two middles, then in that case, we would opt for the node 4. So we again iterate using another pointer starting with node 1 till the count equals to 4. So when count is equal to 4, we just stop there and return this node as our output. So this is the first method. So this is going to take big O of n time to iterate our complete linked list once to find the length of a linked list, and again n by 2 time to iterate half of the linked list and return it. So here we have to reiterate second time to find the middle by knowing the length of the linked list. So what would be a better approach to iterate to the middle directly, access the middle directly in constant time to avoid this n by 2 time. So now we have access to arrays. Arrays are one of the data structures where it let us access its value directly with big O of 1 time. So what we are going to do is we are going to have a list node array or nodes array, however you want to name it. And this array is going to hold each node at each index. So we are going to add all the nodes one by one to the array, and that is going to hold node 1 at array 0, node 2 at array 1, and so on till node index 5 will have node 6. So now by having access to our array, we can directly say what is the length of an array. So by using that, we found the length of our linked list as well. So now we can directly return array of array.length by 2. So that this would actually access to the very middle node in the linked list and return it. So this is one of the shortcut way to access the middle node without being iterated by another pointer and take n by 2 time. So this is going to run in big O of n time complexity. So how do we even make it better? So that's the optimal solution we're going to learn and use whenever we need in any linked list problem. So let's get diving. So now we have seen big O of n solution. Now it's time to even optimize this solution with pointer technique. So we go and use pointers every time we have given a linked list problem. So again, we are going to use the same to get this done as well. So we are going to introduce two pointers, slow and fast, to iterate the given linked list. So what does a fast pointer do is travel two nodes at a time, and the slow pointer will travel one node at a time. So this is basically just dividing the array or linked list into half, because when one moves by 2 and one moves by 1, eventually when the last or the fast pointer reaches the end of the linked list, the slower one would have reached only half distance, because this traveled by double of its speed. So it's the same like any mathematical problem would do. If someone is traveling two times your speed, then at the end you would have reached only half of what the faster person has reached. So it's just another aptitude problem you would apply to this logic to achieve your solution. So now our fast pointer, for every iteration, is going to move two nodes at a time, and the slow pointer is going to move one node at a time, and at the end they both gonna reach the end and mid of the linked list. So first iteration has been moved fast pointer by two nodes and slow pointer by one node. And again in the second iteration, the fast pointer moved to the end of the linked list and slow pointer moved to the mid. Now our fast pointer has already reached the end because the next node is the null, which means our slow pointer is right before our middle node. So we are going to simply return slow dot next as our mid node. So this is going to be the starting of our or mid node of our given linked list, and this is going to be our output. As simple as that. If you understand this logic, you are going to apply this in so many places. So as I said, this is going to only travel to half of the node. This is going to work in big O of n by 2, and constants can be ignored. So overall it is going to work in optimal big O of n time. So hope you're understanding this logic. Let's go to the code now. So as I said, we are going to have two pointers, and we are going to iterate it till our fast pointer reaches the end of a linked list. Then slow is going to move one pointer at a time or one node at a time. And fast is going to move two nodes at a time. So yes, finally we are going to return slow as a mid node. So it is very simple, as I have said. I have initiated fast to head, so this will reach one step after, so I'm going to return slow. If you are initiating fast as head dot next, then you can return slow dot next. It's up to you how you write the code, but the logic is same. So let me run. Yes, let's submit. Yes, the solution has been accepted and runs in 0 milliseconds. So thanks for watching the video. Hope you like this video. If you like this video, hit like, subscribe, and let me know in comments. Thank you.